Thank you very much for the kind introduction. And let me also extend my thanks to F-REI for the kind invitation for ICRP to join you last week and this next week. It's been very fruitful already, and I expect the next few days to be even more so. So today I'll be speaking about the revision of the system of radiological protection, just to give you a broad overview. So Werner already mentioned a few of these points, but let me underline a few more. Probably the most important is that the work of ICRP underlies all ionizing RP standards, legislation, and practice worldwide. I think this is a very important benefit that ICRP brings to radiological protection internationally, because it means that no matter which country we go to, we all use more or less the same approach, if not exactly the same, but similar. We're an independent international organization working for the public benefit. We don't work for industry, we don't work for governments, we work for the public explicitly. In fact, because of this, part of this is that we're formally a charity registered in the UK but working internationally. And we were established in 1928, so we're coming up on our 100th anniversary relatively soon. As of last month, our membership changes a little bit all the time. As of last month, we had 387 members from around the world. You can see from just about everywhere. And 36 from Japan, which is almost 10%. Very few countries can claim to have as large a number of people from their country on ICRP membership than Japan, so that's really excellent. And it says something about the quality of radiological protection experts in Japan. I'll go into a little more depth than Werner did on our mission. So we advance for the public benefit the science of radiological protection by providing recommendations on guidance in all aspects of protection against ionizing radiation. And I underline 3 points because they're the most important in this very simple sentence. I mentioned already the public benefit. It's for the public that we work. Mainly what we do is provide recommendations and guidance. This is sometimes in the form of ICRP publications. We have a dedicated journal, Annals of the ICRP, and this is where the definitive advice from ICRP is recorded. But we also have other fora. I mean, today we're talking about radiological protection. We do it in our international symposia that we have every couple of years. We do the same in our online workshops and webinars that we hold and in many other fora. And we deal with all aspects of protection against ionizing radiation. So no matter where the ionizing radiation comes from, whether it's from outer space, whether it's from the Earth, whether it's from a power plant or a medical procedure, we deal with all exposures to ionizing radiation. So I spoke about our publications and where you find our recommendations, and there are several kinds of publications that we put out. All are in Annals of the ICRP. One are general recommendations, which I'll come back to in a moment. Another are publications on a particular aspect of radiation protection, like protection against radon, for instance, or protection in a particular medical procedure and so on, or deep geological disposal is another example. So many on those kinds of topics. We have quite a few publications that provide tools needed to do radiological protection, the most obvious of which are our dose coefficients, so how to calculate dose in a relatively simple way. And we have publications that assess impacts of new scientific findings, both mainly about hard science, but also about social science. An example is a report that we used recently on cancer risks from uranium. There's one more category of publications that we put out, our proceedings issues. So whenever we have a large meeting, every 2 years mainly from our symposia, we'll also produce proceedings. Just to let you know, there have been about 160, 70 ICRP publications since 1928, and more than 100 of them are translated into Japanese, thanks to several Japanese organizations over the years, currently supported by NRA and undertaken by JANUS. So if you go to the ICRP website, find our publications page, you can click on Japanese translations and read most of our publications in Japanese. So back to the general recommendations. There have been 13 general recommendations since the beginning in 1928. At the beginning, Every 3 years, they were updated at each International Congress of Radiology because the field was new. At least the international field for radiation protection was new at that time. Then, for obvious reasons, there was a gap during World War II. And after World War II in 1950, what was previously called the International X-ray and Radium Protection Committee became ICRP, International Commission on Radiological Protection, in 1950. Again, you can see relatively short periods between new general recommendations during the 1950s, 1960s. And this is not because the world was so new for radiological protection, but because we were learning something very new about the implications for cancer and exposure to ionizing radiation, mainly from Hiroshima and Nagasaki survivors, but also from medicine. So a lot of things changed in the system during this period. And then you can see there's quite a gap between the 1966 and the 1977 recommendations. It's the 1977 recommendations that really set the system that we use today. Of course, there are changes since 1977, many, but the basic structure of the system of protection that I'll show you in just a minute was fundamentally set in 1977. And since then, there have only been 2 updates. So in the last 50 years, only 2 updates, in 1990 and in 2007. So what are these general recommendations? They lay out all of what we call the system of radiological protection. And just to give you an idea, for the current set of general recommendations, Publication 103, I've laid out a simplified table of contents. You see it covers aims and scope, biological aspects, quantities, and so on. So very general ideas of radiological protection. And I'll speak about many of these in just a moment, because now what I'd like to do is give you a sense of what's inside this box of radiological protection. Really, the fundamentals are science, ethics, and experience. We need scientific understanding, and it must be based on good science, of course. Radiological protection is not only about science, it also needs strong ethical principles so that we can make judgments on what's good and right. And of course, practical experience helps us understand what's reasonable to do, because in the end, radiological protection is a practical undertaking. I'll speak about these 4, let's say, big pieces of the system of RP: the primary aim, protection goals for both people and the environment, a little bit about our fundamental principles, and just a few seconds on the larger toolbox of concepts, tools, and requisites. So let's start with science. Science is at least one kind of knowledge based on evidence, effectively. And it helps us understand things like effects of radiation exposure. It's the most obvious. But it's not only that. We use science for other things, like how if you inhale a radionuclide, it moves through your body, so we can understand how dose deposits in your body, and we can assess dose, and so on. So you use science for many aspects. In fact, it's highly interdisciplinary. You can see, and I won't go into the details of all of this, but you can see physics features highly. Chemistry is very important, especially for the way radionuclides move through the body or through the environment. Biology and ecology are crucial. Even mathematics and computer science, which you maybe not think of immediately, but mathematics and computer science allow us to do things that we couldn't do, well, our predecessors couldn't do in 1928 or even 1950. In addition to the science, as I mentioned, ethics is crucial. It's a guide to what is good and what is right, so it helps make decisions on actions. We've identified 4 core ethical values. One is about doing good and avoiding harm, which we call beneficence and non-maleficence. Another is prudence. It's a bit like wisdom, or being able to make good choices even without full knowledge of the situation and without full knowledge of the consequences of an action. Justice is also crucial. This is a kind of distributive justice that we focus on in ICRP, so that there's a fairness in the distribution of advantages and disadvantages. And dignity also is a key core ethical value. All of these are equally important. And this is about making sure all humans, all people are treated with dignity, with unconditional respect for every person, regardless of their situation. An important corollary of this is personal autonomy, so the ability for people to choose their own path. In addition, we identified 3 procedural values, and these help with the practical implementation of radiological protection. Accountability, transparency, inclusiveness. I think you're probably well familiar with these concepts, so I won't go into them in depth, other than to say they are also crucial to radiological protection, in particular the implementation. So moving on from, let's say, the scientific and ethical basis, the first stop is the primary aim of the system of RP. And really, if this is all you remember, maybe it's not so bad, because this encapsulates all of what radiological protection aims to do. It's about contributing to an appropriate level of protection for people and the environment against detrimental effects of radiation exposure, without unduly limiting the desirable human actions that may be associated with such exposure. So here you can see it's often a balancing act. We want to make sure people and the environment are protected, but we also don't want to limit beneficial uses of radiation. For instance, in medicine, it's the most obvious example. Radiation therapy, radiation imaging is incredibly beneficial. So there's always a balance between protecting people and enabling positive uses of radiation. Below that, we have 2 protection goals, one for human health and another that I'll get to in just a moment for protection of the environment. So the protection goals for human health are just this simple. We manage and control exposures so that harmful tissue reactions are prevented and the risks of stochastic effects are reduced to the extent reasonably achievable. Maybe that's a little bit complicated, so to put it even in a more simple fashion, in principle, some effects can be prevented because at low doses they don't occur. And these are tissue reactions. So if doses are below a particular threshold, there is no effect. So we aim to prevent these effects in almost all cases. Stochastic effects, on the other hand, like cancer and hereditary effects, for instance, in principle don't have a lower threshold. At least that's how we protect against these kinds of effects. So it's impossible to 100% avoid these effects. There's background radiation, or at least the probability of these effects anyway. So the idea is to manage radiation exposures, to reduce the probability of them to a reasonable extent, as much as is reasonably achievable. Protection goals for the environment are somewhat different, in part because the diversity is enormous. There's one kind of human species, but there are billions of species of animals and plants. The goal here is not to protect every individual animal and plant, but to prevent or reduce the frequency of negative effects so they have a negligible impact on biological diversity, conservation of species, and protection of habitats, communities, and ecosystems. So at a glance it looks quite different, but the general principles apply the same to both. Below these 2 objectives for protection of human health and protection of the environment, we have some fundamental principles that we use in pretty much all circumstances. The first is justification, making sure that any action that's taken does more good than harm. Pretty straightforward. The second is optimization of protection, and you can read the long sentence here, but basically it's just doing your best for protection, given the particular circumstances you find yourself in. And the third is individual dose limitation. So don't exceed the doses that are set out in the ICRP recommendations or in the national legislation in your country. And the point here is to make sure that no single individual shares an undue burden of risk. Why should one person get a very high dose and another person get a very low dose if you can manage things in a better way? So we add dose limitations so that individual people are protected. And then below that are many things that I won't get into in depth because this takes a long time to develop many of these key concepts. We have exposure situations that talk about whether the exposure is already existing or it's planned activity or an emergency. We have categories of exposure depending on whether it's in a medical setting, for a medical patient I should say, occupational or public. We have criteria, usually expressed in dose, but not always. So I'm sure you've heard of dose limits, for instance. Even dose itself is a concept. And then there's other requisites like information, training, monitoring, etc. But I won't go any further with that. Because what I'd like to do with the next part of the presentation is talk about what we're working on right now. So you saw towards the beginning of the presentation the first 13 sets of general recommendations, and now we're working on a 14th set of general recommendations, the next general recommendations. It's not because the current set is broken, it works, there's little doubt about that. It could use some improvements, that's one reason we're looking at it. But most importantly, we have to adapt to changes in science and changes in societal expectations so that it continues to be effective in the future. Can you imagine if we still use the 1928 recommendations? We wouldn't be looking at cancer even. I mean, it would be out of date. And there's a lot of advances that have happened in the last quarter century, since, even more actually now, since the last general recommendations started to be reviewed. So we initiated this in 2018, roughly. I could be off by 1 year. We initiated this review and revision of the system for protection to lay the groundwork for the new general recommendations, so the successor to what's now Publication 103. The idea is that it will then be the foundation of RP standards and practice worldwide for the next generation of practitioners. It'll be the next generation of recommendations. And in fact, it's important that the next generation of practitioners are involved in developing this because it's them who will be using it. Werner and I won't be using the new set of general recommendations. We'll probably retire shortly after or even before, but some people in this room may be. So we're really trying to attract younger people, younger researchers. We have a mentee program that really invites many into ICRP so that they can be involved in help with putting together the next general recommendations, and then they'll be the ones using it in the future. The general process looks simple. Obviously, nothing's as simple in real life, but the beginning was to identify which topics we should cover, which aspects of the system, the ones that I talked about just a few minutes ago, which aspects of this system should be reviewed. And after several years of consultations with many groups around the world, we think that we've got a good list of topics to review. That doesn't mean we'll ignore if new topics come up that we won't need to cover. Of course we will. But now we're focusing on the second phase, which is as we climb this mountain to develop these building blocks, what we're calling building blocks, these topics, through ICRP task groups. And then towards the end of the process, we'll put together all of these building blocks to build the new general recommendations. The scope is quite enormous. Since publication 103, we've had about 55 new publications. So there's a lot of information there. Not all of those publications will impact very strongly the new general recommendations, but many of them will, no question. We also have 30 task groups working right now on a variety of topics. And you heard Committee 4 met just last week, finishing yesterday. Almost a third of them are up to Committee 4. So the Committee 4 has quite a big job. And we have 15 more topics we've identified, but not yet begun. Not because we're waiting, and just for reasons for waiting, mainly because these are topics that are better tackled once we've addressed some of the earlier issues. So in the next couple of years, we'll be initiating some more task groups to deal with the topics that need to come later in the process. And this adds up to nearly 100 topics in the system of radiological protection, which is really staggering. When we started the process, I never did the math to see what that number would be, but it's big. So rather than try and describe 30 task groups, it'll take a very long time. I just give you a sense of the areas that they're covering. So there are 7 task groups working on effects. And by the way, these numbers are approximate. There's overlaps between task groups. Some might be working on multiple things, but 7 are focusing on radiation effects. 7 more are focusing on radiation dose. 3 specifically on the environment, but there's others that touch environment as well, quite a few others. 2 specifically on ethics, but again, ethics is quite a broad topic, and many of these other task groups look at ethical considerations as well. 2 focusing on 2 of the 3 fundamental principles, and we'll likely launch another task group in the not too distant future to cover the 3rd fundamental principle. Remember, justification, optimization, dose limitation, the 3 fundamental principles. We have some task groups addressing other concepts, for instance, RP in biomedical research, looking at different exposure situations and categories, and the idea of individualization and stratification, or how to deal with the possibility of some people reacting differently than other people to the same dose of radiation. And there are a number of task groups looking at specific activities, so a number of medical specific task groups, looking at emergencies, looking at waste issues, and so on. So quite a diverse set of topics. As I mentioned earlier, ICRP is very reliant on a wide variety of experts to do our work. And just to wrap up, this is not meant to be a one-way communication. Of course, there'll be time for some questions now and later, I think. But also, you can interact with ICRP anytime you want. You can follow us on social media. We have a fairly strong social media, well, team is strong, but we have a couple of people working on social media. You can attend our online webinars. So for each publication, we'll have an online event that you can attend to hear about what we've finished developing, for instance. When we have a new publication a few months later, we'll have a webinar you can attend, listen, ask questions, but also during development of publications. While it's still in draft form, you can attend a webinar, workshop online to listen to hear what's going on and give your feedback. And it's also possible to comment on drafts for publication, or for public consultation. Every single one of our publications before going out, we release a draft online. There are several months during which people can comment, and we accept comments from anyone. You don't have to be in a research institute. You can give your own comments directly to ICRP through this public consultation process. And I think almost on time, that's it. So thank you very much for your attention.